are going to explain about the project titled Progressive Learning for Person Re-Identification with one example. Person re-identification aims at spotting the person of interest from non-overlapping camera views. In recent years, deep convolution neural network has led to the impressive success in the field of re-identification. Most existing re-identification methods, in particular, deep learning model adopts the supervised learning approaches. This method relies on the full annotations, that is the identity labels of all the training data from the multiple cross video cameras. However, it is labor intensive to annotate large scale data. The intensive human labor may limit re-identification applications, especially when there are many cameras. Recently, there are a few semi-supervised person re-identification methods. We focus on the one example setting in which only one example is available for the each identity. The setting is more challenging but provides a much more cost-effective solutions to the real-world re-identification problems, where cross-camera annotation required substantial annotation efforts. The main objective of this problem statement is to predict re-identification of a person by using different datasets, pseudocode labeled dataset and unlabeled datasets, and also using the model CNN algorithm. Hardware requirements: operating system Windows, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. Software requirements: we need to install Python with the version of 3.7. Coming to the methodology, to implement this project we have designed few modules that are: first one, upload label dataset. In this application we are going to upload the dataset to this application. Then next module, upload pseudo label dataset. In this module we are going to upload the pseudo label dataset to this application. Third module, build a training model. In this model we are going to divide the dataset into the two parts, training and testing, with the 80% of the dataset application for the training and 20% of the dataset application for testing, to train and build the algorithm. Then next one, generate a CNN algorithm with the label and pseudo label datasets. In this module we are going to train the CNN algorithm and build the model based upon the labeled and pseudo labeled dataset and test them with the pseudo label and labeled dataset and get the accuracy, precision and recall effect score. Now next one, module person re-identification from the index. So in this module we are going to find the person re-identification based upon the index label which are imported for the testing the CNN algorithm. Then last module, that is accuracy and comparison graph. In this module we are going to plot the graphical representation of algorithm which we have used in this project and also showing them the accuracy levels. Coming to the execution, close this file and go to the code file. Now this is the code file, consists of index label and also pseudo label, and these are the few labeled data sets which we have. And next one, this is the model file which consists of different file formats: pickle file, .npy file and .hy file. Pickle file is a serialized data format in Python used for object serialization. It allows you to save Python objects into a file and later load them back into the memory. Then coming to the .npy file format, it is a standard binary file format in NumPy for persisting a single arbitrary NumPy array on disk. The format stores all the shapes and data types information which are necessary to reconstruct the array correctly even on another machine with a different architecture. Then coming to .hy file, this .hy file contains algorithm information and can be loaded into the project code during runtime to utilize the trained model for various tasks such as making prediction on the new data or performing specific operations. Then next one, these are the video file, consist of video data which are used for training the CNN algorithm without training the data. And these are the main code files, and this is runbat file. Instead of executing the program in command line interface, we created Windows runbat file to execute the program. By clicking double tap on it, it leads to the user graphical interface which is interactive to the program user. And now here you can see that first button, click on the first button, upload label dataset. Now select the label dataset and select the folder. Now you can see that label dataset is loaded. Then next button, upload pseudo label dataset. Select the pseudo label dataset and upload it. and you can see the pseudo label dataset is also uploaded. Now build the training model. Here we are going to build the training model, and this is the sample of the training images which we generated for the training uploaded videos, uploaded images. So here you can see label and pseudo label training model was generated. The next one, generate CNN algorithm with label and pseudo label. In the back console you can see the CNN algorithm was generated with the dimension of 62, 62, 32, 31, 32, 31, 32. So these are the dimensions and CNN is ready. So you can see that on the graphical user interface the accuracy of the CNN algorithm here, and then generate CNN algorithm with extension Gabber features. Gabber filters are known as best to depict the mammalian multi-challenge approach of vision for interpreting and segmenting textures. This notebook shows that an implementation of Gabber filter in the Python using skline and other libraries to segment textures within an image. Now while clicking this click, and you can see here this is the original image and this is the Gabber filter image. So you can see the high intention of segmented textures here. So this is the main feature of Gabber filter. Now close this one and go to the next button, person re-identification from the index label. By clicking this button you can select any of the person image and click on the open. So it will be identifying that person and it will show. Now next click on the other button, that is progressive and Gabber, progressive accuracy and also loss graph. By clicking this button you can see the graphical representation of Gabber, CNN algorithm and CNN algorithms graphical representation of accuracy and loss graph. In the x-axis you can see the iterations found, and in y-axis you can see the accuracy or loss graph. CNN algorithm consists of loss and accuracy graph. So here the yellow line indicates the accuracy levels and the blue line indicates the loss graph. So iterations increases, the loss decreases and the accuracy increases. Now close this graph and click on the next button, that is person re-identification from the video. By clicking this button you can select the video and click on the open button. The video will be generated and the persons will be identified. So you can see here the persons count number is identifying in the back console. So now close this one, exit the code and go to the conclusion. So in this project we have found that by using iterations trained with the CNN algorithm model and also estimated pseudo labels for the unlabeled data, we have got the perfect best accuracy score in this project in predicting the re-identification of a person.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.